Alrighty, on this lesson here, we'll be on lesson 3.4, which will be other common functions. So we've talked about linear, quadratic, and now we're just going to talk about all the rest of them. So after reviewing it, I do feel that I'm just going to kind of give an overview of all the main functions, and then I'll do a few examples for you, and that should kind of line up for your homework. As always, if you need more examples or help, feel free to email me or post in the discussion. I don't mind making more videos or more examples. All right, so for starters, let's talk about power functions. And basically what you need to know here is you have your linear functions, which are in the form of f of x equals x. And they basically look like a straight linear line, either a positive, a negative, or a zero slope, all in the different kind of forms. The other types is you have what they call cubic, which is f of x equals x cubed. They do a pattern like this. And then pretty much after that, all functions that have a odd exponent will make a shape like this one. So that would be x to the fifth, x to the seventh, x to the ninth, and so on and so on. So you see any of these forms, it's going to make some type of shape that looks like this. So that's basically the gist there of those power functions of odd. Then we go into quadratic functions, which are in the form of f of x equals x squared, and they make a parabola. But what you need to know is pretty much all shapes of even exponents make a shape similar to a parabola. So that includes x to the fourth, x to the sixth, x to the eighth, and so on and so on. So if it's an even exponent, it's going to make some type of parabola shape. All right, then you have functions of what we call rational functions. Oh, add an extra I there. Which are basically, in a more common language, fractions. So if we have f of x equals 1 over x, we will get a graph that roughly looks something like this. They have what we call branches, one in quadrant 1 and one in quadrant 3. Basically, any rational function that has a odd exponent will look like that. So that's like 1 over x cubed, 1 over x fifth, 1 over x seventh, and so on and so on. Another form of these rational functions can be written with negative exponents. So you could see it as x to the negative 1, x to the negative 3, x to the negative 5, and so on and so on. But it's the same thing. So 1 over x is the same thing as x to the negative 1. Another type of rational function could be written as such, 1 over x squared. These shapes are going to have one in quadrant 2 and in quadrant 1. And again, these will be for even exponents. So you could have 1 over x to the fourth, 1 over x to the sixth, 1 over x to the eighth, or again, could also be written as x to the negative 2, x to the negative 4, or even x to the negative 6, and so on and so on. So this is the parent function, but just realize that even with the linear functions, if they are negative, it would be a negative slope. We know with negative quadratics, so just so you know, this is the form of a negative function. And the same thing over here, if I have a negative function, then it'll just kind of do that. And if I have a negative quadratic or an even exponent, it would be a function that looks like this. So when we're talking about a function in which it ends up something like this, realize that the branches will just flip over as well. Same concept if we get one like this. And so they'll be in quadrant 3 and 4. Um, oh, other ones are what we call radical functions. Those are basically your root functions. So most basic one that y'all know, the square root of x. I like to call it like the Nike mark upside down, but it kind of does something like this where it starts at 0 and goes there. Um, and then and that's pretty much like what every even exponent. So realize that this can be written as x to the 1/2. So we'll say an even denominator. Or if you want, you can even say index. Remember, the index is this little number here. So it can be written as the 4th root of x, the 6th root of x, so on and so on, or even x to the 1/4, x to the 1/6, and so on and so on. And then, of course, if it is a negative, it would literally just go the other direction. So again, instead of this way, we now have one like this. And you can think about it too, and we'll get to this point, but if you ever forget what direction it goes, you can always just plug in numbers. So if I plug in like a 9, which is like right here, and then it becomes a -3, then that's going to be right here. Or if it was a positive, then it would go right here. So you can always kind of plug in, which is what we'll kind of go over here later. The other types of radicals are, of course, your odd ones. So like the cube root of x, also known as x to the 1/3, basically takes what that cubic function was that looked like this and basically turns it sideways. So that would be a cubic, and then also a negative version of that. Be something like this. And again, we'll call this our odd denominators, or also your index, depending on what you're looking at. So the cube root of x, 5th root of x, and so on and so on, or x to the 1/3, x to the 1/5, and so on and so on. And then, of course, you have your absolute value functions. And when you first learned about absolute value functions, it was the introduction to what they also call piecewise functions. So this is what a absolute value is, basically makes a v, and of course, a negative version of that. And then a second one that we kind of talked about, kind of get into piecewise function, is what they call the greatest integer function. And it looks like this, where it looks like it's a double bracket. As such, not the best drawing, but you kind of get the picture. And it's like what we call a step graph. So it kind of looks like this right here. I'm gonna use a different color. Where basically it looks like steps. And basically what it means is whatever value is going to go here is going to go to the um, largest integer that is either less than or equal to the value in here. So for instance, if I put in, let's say, well, let's do this. I ask you what the value of 4.3 is, the result would just be 4 because that's the largest integer that's less than or equal to this value. Same concept if I go with this, negative 2.9. The answer would be negative 3. Can't go to negative 2 because negative 2 would be larger than this value. It has to be the largest integer that is less than or equal to this value. So if I was to do just a straight up 2, now my answer is 2 because it can be equal to or less than whatever value that is. So you get this kind of function here. And then after that, you kind of get into, from there, we got into piecewise functions. Which is literally named that because it's literally pieces of all these different functions. So you could have things that look like this, where you have a piece of a linear and then a piece of a quadratic, or a piece of an absolute and a piece of a x or square root function, something like that. But it can just have different pieces of it, so it makes it kind of piecewise defined. All right, so that's pretty much the gist of all 3.4. So I figured I could go kind of go through some different examples. So if we look at number 1, basically like all the questions through the first 36 is asking you just to sketch the graph, and then just be able to like locate points and stuff like that. So if I was to give you f of x equals negative x over 2, to be able to graph this, you just need to realize that, hey, this is the same thing as negative 1 over 2x. So therefore, this is going to look similar to a linear function. A negative linear function. So you know your function has to look something like this. So to get specific values, you can just plug in some random points. Choose negative 1, 0, and 1, or whatever other random. I actually might change that up, and I think I'm going to use negative 2, 0, and 2 as my x values. And the reason I would do that is so that when I multiply, I get nice clean numbers. So like negative 1/2 times negative 2 is a positive 1. If I would have chose 1, I'd had fractions. But 0, I get 0. Here, I get negative 1. So you want to choose numbers at your discretion. You get to use whatever numbers you want, but nice numbers that will come out also with nice numbers. So when you graph this, you can see that you have negative 2, positive 1, 0, 0, positive 2, negative 1. So you get something like this. So you have a good few points in the right direction. Right? That's pretty much all you really got to be able to do. So we'll do a few more. So let's look at number 6. It says q of x equals negative cube root of x. Again, because I can look at this, kind of one of my parent functions, I know a positive cube root is going to do something like this, but then a negative one will do something like this. And again, choose some good values. I know, I guess really you could do negative 1, 0, and 1 in this situation. You could have done negative 8, 0, and 8. Well, they're kind of the other numbers going in my head. But the cube root of negative 1 is negative 1. Apply a negative makes it a positive. This would be 0. Cube root of 1, meaning what number times itself 3 times will give you that result, is 1. Apply the negative. So notice I have negative 1, positive 1. 0, 0, and then 1, -1. So it's not going to make a straight line. You got to know that the function is going to have a little bit of a curve. And that's pretty much like all you got to be able to do. So let's see if I can make it harder. Let's look at number 7. So look at g of x equals negative absolute value of x. This is another parent function that we just saw. You got to realize this is an absolute value function, what makes a v. And because it's negative, now it makes an upside down v. And this one, again, just choose simple numbers. Don't make your life hard. I generically do 3. I don't know how many the homework's going to do. I think the homework makes you do 2. So the absolute value of -1 is a positive one. Apply the -1, so it's -1, which makes sense. Zero absolute value of 0 is 0. Apply the negative, it's still 0. Absolute value of 1, apply the negative, is -1. Again, makes relative sense. All right, let's see another one. So you might get something like k of x, sorry, number 8, equals 1 over x cubed. So you gotta see, all right, this is a rational, so it's gonna have the brackets, or it's not bracket, branches, and because it's odd, you gotta realize it's gonna do something like this. So you can't plug in 0, but plug in whatever other numbers you want. So I'm gonna go with -1, 1, 2. I literally don't think it matters on the homework. So this would be 1 over -1 cubed, which would just be -1. 1 over 1 cubed is just 1. 1 over 2 cubed is 1/8. And then you just kind of plot those. But just to get an idea, if I go -1 down -1, I'm somewhere on this branch. If I go +1, 1, and then -1, I'm somewhere on this branch. +2, I'm closer to this branch, but I'm in the right quadrant. All right, let's see if I can get another one. Let's look at number 9. G of x equals the square root of x over 2. So you got to realize, hey, this is a fraction, not a radical. So it could be written as 1/2 times the square root of x. So I know I'm going to have something that looks like this, but that 1/2 is going to adjust it a little bit. But I know I need something like that. So what I'm going to think about, because I want to come up with nice, clean numbers, is I want to think about all my squares, perfect squares, and then I also want to think about even numbers. So I think I'm going to go with a negative. Can't do negative. So let's go with I can do 0. That'll come out nice and clean. I can't do 1 because that'll be a fraction, but I can do 4 because that would give me 2. And let's do one more. Don't want to do 9. I could do 16. So these are the numbers I'm going to choose, but be strategic with it so they come out nice. I think that specifically wants you to do that on the homework too. So the square root of 0 is 0 times 1/2 is 0. Square root of 4 is 2 times 1/2 is 1. Square root of 16 is 4 times 1/2 is 2. And so you can kind of see it's going to make somewhat of that shape. So 0, 0, 1, 2, 3, 4, 1. And so it'll be something like that. Alrighty, let's look at another one. Let's look at number 15. So h of x equals 2 times cube root of x. So again, I see that's a cube root. So I know I got to have a function that looks something like, oof, that was pretty bad. Let's try that again. So something like that, a defining curve there. And then it's going to be times 2. So it's probably just going to be stretched out a little bit. So again, when thinking about my numbers, I'm going to think about nice, clean cube roots. So that's -1, 0, and 1 to me. So the cube root of -1 is -1 times 2 is -2. Cube root of 0 is 0 times 2 is 0. Cube root of 1 is 1 times 2 is 2. So when I make my function here, I have -1, -2, and then 0, 0, and then 1, 2. But you got to realize it's going to do something like this. That is that little curve, not a straight linear line. All right, let's look at another one. So let's look at number 24. This one is m of x equals x over 2. So again, we know this is going to be a step function looking kind of like this with some open circles and some closed circles and things like that. So ideally, let's come up with a couple of points so we kind of have an idea. Again, I want to stay pretty clean, so I'm going to choose -2, 0, and 2. So when I plug in -2, I get -1. When I plug in 0, I get 0. When I plug in 2, I get 1. So when I'm thinking about this, I'm going to think about all the numbers between 0 and -2 is going to be between 0 and -1. So here's -2. So if I plug in anything between 0 and -2, so -2 itself, here's -1, will be a solid dot here. I got to do a different color. Be a solid dot here, and then 0, 0 is a solid dot here. So that means there's going to be an open dot right below it. And if I keep going, if I do 2, 1, that's a solid dot. That means this is an open dot right below it. Oh, gosh, messed that up. Sorry, the open dot will be right here and be located here. So 2, there it is right there. And then if you want it to, you can see that's this going by 2s now, and then going down by 1. However you want to make that. I think you only need 3 good I think 2 good points really, and kind of go from there. All right, so let's look at piecewise functions. So let's look at number 26. So this is g of x equals -x squared if x is less than or equal to 1, x squared if x is greater than 1. On these type of problems, it's just going to ask you how to evaluate. So it's going to ask you like, hey, what's g of 1? What's g of 0? And what's g of 2? So to figure out where it goes, you got to figure out which function am I going to look at. Well, here's 1. X is less than or equal to 1. So that means that I would only plug it into the first equation. So that's going to become -1 squared, which is just -1. That's it. I don't plug into the other one, only the first one, since 1 is less than or equal to 1. Now, if I look at 0, 0 is less than 1, so I'll plug it into the top equation again, giving me 0. If I look at 2, 2 is not less than 1, but 2 is greater than 1. Therefore, I'll use the bottom equation. So that would be 2 squared, which is 4. So be able to know exactly which value to plug in depending on where the x value falls. You don't plug it into all of them, only the ones that you fall into. So let's look at number 27. Number 27 says r of x equals 1 over x if x is less than 1, and -x if x is greater than 1. So a lot of the questions that are asking you is a 3-part question. It's going to ask you identify the first equation, or the general shape of the first part. So 1 over x. So in this case, I know the general shape looks like this. Part 2 is going to ask you to identify the second part of the shape. And I know that that's going to look roughly like this. And then the third part is then going to ask you to put it all together. So the best way to do that is what I teach students is I'll say, go to your breaking number. So in this case, a 1 is that breaking number, right? Graph everything to the left of 1 for a 1 over x. So I know it looks roughly like this. So I know that this side will be over here, and then I'll have a beginning part. So if I plug in 1, I'll get 1, but I'll put an open circle because there's no line underneath the inequality. And then I'll just kind of sketch up from there. So I know that that's my first part of the left side. The right side from 1, I'm going to also plug it in, and I get -1. And I'll put an open circle again because there's no line underneath it. And then I know that the shape is going to go down. So this is what your piecewise function would look like. This is the general shapes. And then you kind of figure out the breaking number where those open circles are going to go to. Now, if I had a line underneath one of these, then of course it would get a solid circle because then it's included. All right, I just have one more question, and I think you would have a good idea of how to do these. So on number 44 here, I know it says to like match, but I want to do one of those identifying shapes again. This will give you an idea. So f of x equals -4x minus 12 if x is less than or equal to -3, 5/10, which I don't know why they don't just say 1/2, x squared if x is greater than -3. And again, that first part is going to ask you to identify the general shape of that first function. And I know that this is basically a negative linear line. So I know it's going to look something like this. Of course, adjust it downwards to maybe get a better idea. Something like this, where it's going to be a negative slope, but it's going to go through a negative y-intercept. Then you're going to be asked to identify the general shape of the second part. Which is they say 5/10. Again, could just say 1/2. But I know that that's a positive parabola, so I know it's going to make some type of shape like that. It's not going to adjust it up or down. So then to put this all together, I see that my breaking number is at -3. So that's where I'm going to start. So -3, if I plug in, will give me 12 minus 12, which is 0. But it has a line underneath the inequality, so it's included. So I'm going to have an open circle. And since I know the shape looks like this to the left, you can get another point if you would like, but I pretty much know it's going to do something like this. But if you want another number, choose -4, because that's less than that. And that'd give you 16 minus 12, which is 4. So then you can go, all right, well, 1, 2, 3, 4. At -4 puts me like right here, right? If you want another point, but really and truly, since you know what the shape looks like, just draw it to the left. Do the same thing with the next one. So I got -3. I plug it in. That gives me +9. 9 times 5/10 is, well, really 9 times 1/2 is 4.5, right? So I'm going to go to -3, and at 4.5, which is roughly, here's 5, roughly like right here, I'm going to draw a open circle, right? Because it's not included. Now I know the shape looks like this. So I know if I was to plug in 0, I would get 0. So if you need a reference point, and then I'm going to shoot up somewhere like this. So I have a general idea. I have a linear line, breaking point, quadratic from there. All right. If you need some more points in there to make it more specific, by all means, add those points in. I don't know how sensitive that homework's going to be. Again, if you end up needing more examples or more practice with anything, reach out, let me know. Again, as an online class, I don't really know what you're struggling with unless y'all ask. If I don't ever hear anything from y'all, I can just assume you are masters at this and you're going to make an A on the test. Hope you are enjoying it so far. See y'all in the next video.